Alright, so I was dumb enough to record all this without my microphone plugged in. So, yeah, I'm feeling extra smart. So, what we're going to do is we're going to record me watching me do this. So, if you see this cursor and then this cursor, don't freak out. Okay? Alright, this is going to go. I set it to fast forward. So, we'll actually do this pretty quick. Alright. So, start off, here's a nice graph of our scores. So you can see some of them are good, some are okay, and some are pretty terrible. So we're going to go over the questions to help the people that are over here, and some of these people over here get better understanding. Right? So let's get started. Maybe. Then I gotta wait for me to go to the next thing. Alright, number 1. Figure shows tower and a cable suspension bridge. Given that AC is congruent to BC, use SAS to explain why they're the same. Look at me go. Look how quick it is. Okay, so we need two sides and then the angle between them. So it's given that we have this one side. Given, right? We have our right angle here. And if we consider linear pairs, we can say that its supplement is also a right angle. So you can also use supplements theorem. Like, it's going crazy. Okay, since they're both right angles, they're congruent because that's the right angle theorem. And then they share a side, which is a recurring theme on this quiz. So that's a reflexive property. So that gives us side, angle, side, and that's the answer. Okay, and that was worth 10 easy points, which I should write down right there. Okay, question 2. We needed a flowchart for this one. It's given to us. JK bisects. Oh, I need to draw triangles. JK bisects MJN. Come on, go faster. Alright, start with the givens. JK bisects MJN. Given. It's also given that MJ equals NJ, as indicated there. So that gives us one side. So we just need to establish two other pieces of information. So if JK is a bisector, I should erase all this because it looks kind of messy. Oh, look, there I go. So JK is a bisector, which means the two smaller pieces of that have to be congruent to each other. So MJK congruent to KJN. And that's the definition of bisectors, angle bisectors. Okay. And then we look what else we know. And again, it shares a side. So JK is congruent to itself for serious, not for JKs. It's a reflexive property of congruence. So that gives us one side, one angle, and another side. So if we put that together and draw some arrows indicating our side, angle, and side, we can say that the two triangles are congruent to each other by SAS. And that's what we're looking for. So that's it. This was 20 points. And then we point out some mistakes that people made in putting the arrows in. The arrow should only correspond to a step that requires that information. So some people said that MJ is congruent to NJ and that had something to do with these angles, which makes no sense. Some people said that the angle bisector had to do with the side being congruent to itself. Also doesn't make sense. Don't just put in arrows because you think they need to be there. Only put them in a logical sense. Okay? Alright, the next 4 were pretty straightforward. We had to prove they're congruent using HL. So we needed one hypotenuse and one leg to be congruent. So if you look at number 3, they share the hypotenuse. They have a leg in common. So the answer is yes. The other one, they share a leg, but we know nothing about the hypotenuse. So we cannot say they're congruent. So we put no, because we need the hypotenuse. And then we show how we could draw that same triangle with everything given to us and show they definitely don't look the same. Because the original one, they looked right, but you can't assume they're right. Alright, 17 and 18. These were pretty simple because they were congruent, and you didn't really have to prove it, but you could have. After that, it just becomes an algebra problem to say that the corresponding sides are the same, so you set them equal and solve for x. So 17, this was side, angle, side. 18, angle, side, angle. Both don't work out the same way. You just do the math, and you get two answers. Most everybody got these right, so that's good. Alright, number 7. This one was, there was a lot going on here, and the way you looked at it changes things. And Roethlisberger throws a terrible pass. Go Pats! Okay, so wait, hold on. Oh no, we're okay. Okay, so we're trying to prove these two angles are the same. One thing you could have said is 2 pairs of parallel sides makes a parallelogram, which technically is true. And then if they're parallelogram, opposite angles are congruent because that's the definition of a parallelogram. But our goal was triangles, so we're not going to look at it that way. And nobody really said it correctly enough that I could accept it. So if we extended these out, we can see that we have parallel lines that are connected by transversals. If you have transversals, it means you have alternate interior angles, and those are always congruent. So that gives you 2 angles. And then again, the recurring theme, the shared side, gives us, there it is, congruent side. So now we have angle, side, angle. And if you have angle, side, angle, that's enough to show they're congruent. And if they're congruent, you can use CPCTC to something I wanted to say. Oh yeah, that they're congruent. CPCTC does that. Okay, so take a minute. I'm gonna write out all these steps. So two parallel lines, 2 pairs of parallel lines, congruent. That's given. This should be angle DCE. I know it looks like a C, but imagine that's an angle sign. So these 2 pairs of angles are congruent, and that's both because of alternate interior angles. You could have put these on separate lines and put alternate interior angles theorem twice, or you could just put it all together, whatever. Okay, then our shared side. So our segment CE is congruent to itself because the reflexive property of congruency. That's enough to give us a congruent triangle. So we list those as being congruent to each other. Triangle, okay. Angle, side, angle. If we have angle, side, angle, we can say the last angle is congruent by CPCTC. Alright, one mistake. Oh wait, there's more to this. Now let's do the mistake part first. One mistake people are saying is, I don't know if they were confusing parallel with congruent, because they were putting that these were parallel, that's given, and then they just jumped down and said they have to be congruent by side, side, side. Just because these are parallel doesn't mean they're congruent. I mean, in this one they are, because it's a parallelogram. But we don't know that, so you can't just say it. You have to be able to prove the stuff that you say in a proof, right? Proof. That's like the whole thing. Okay, the other way you could have looked at this was to take the alternate interior angles. That gives you 2. If you know 2 angles of a triangle, we can use the third angle theorem to establish the third here. And since these 2 are the same, that means the third angle has to add up to the same thing on either one, which gives us the statement we wanted, but does not show that the triangles are congruent. But really, this problem didn't say we needed them to be congruent. It's just that. That's what we've been doing all this time, so it's good to practice. Okay, last one. Puppies. I kind of went quick on this because I was already getting bored of doing this. We say that we didn't need question A because to answer question B, you need to answer question A anyway, so we just sort of roll them all together. Because to show BD was the same as CD, you had to show the 2 triangles were congruent. So if we look at it, this is where I get confused and think this is the exact same question as number 1, because they look the same, but it gives us different information what we want to prove, so slightly different. Okay, this one's a little tricky. It wasn't tricky, it was just different in that they didn't say those two sides are the same, these blue ones here. Hold on. Oh no. Hold on. Because it didn't say these blue ones were the same, but they're both 20. And if they're both 20 inches, it means they have to be the same. So really, it's given to us that AB is congruent to AC, right? Okay. So that's our hypotenuse. We look at our right angles. Same thing we did in the first one. Linear pair, congruent supplements, not congruent supplements, linear pair. Makes it a right angle. Right angle theorem says those are congruent. That makes these two right triangles. They share a side, which means we have the hypotenuse and leg, which means we can say these triangles are congruent by HL. Right? And that's the whole answer. Once we prove they're congruent, everything else gets easy. So we write in our steps. First one is a given, which is indicated in blue. Then with the given part of our right angle, call it a linear pair. Call them congruent because they're right angles. That gives us our congruent angle there. We look at me waggling my pen around anytime. Alright, that shared side is reflexive, which gives us hypotenuse and leg, which makes the two triangles congruent, and then CPCTC to show the missing side. And that's it. Alright. The next question, which should have been easy, since you didn't need the proof, you just had to know how to find sides of a right triangle. So if it's 10 and 20, use a squared plus b squared. Fill in our numbers. Work it out. 100 plus b squared is 400. We then simplify, and we get b is about 17.3. We had a surprising number of people putting 23 because they added 400 plus 100, which doesn't make sense because the leg has to be shorter than the hypotenuse, so it had to be about 17.3. Alright, and D, most everybody got it right. Are the puppies congruent? The answer is no, because there's no numbers. Would have been the easy explanation. Like I said, they don't look anything alike. That also would have worked. That was supposed to just be 5 extra points at the end because I'm a nice person. So, one person put yes, so that's why they got the sad face. How are you going to say that? Right, that's quiz. I don't know what I was pointing at. Then we talk about these kids over here, which didn't do so good. So to help them out, on Wednesday after school, there will be a makeup quiz. And that's about it. Right? Come in Wednesday after school if you're not happy with your grade, and we'll give you a brand new quiz with brand new proofs to proof, and it'll be a lot of fun. Alright, so sorry if this went kind of quick, but this is the second time I've done it, and I'm super bored with it now. Alright, so have a good night. Like, comment, and subscribe.